to find magnetic field at the center of the circular section of a wire. This is a circular wire carrying a current in the given direction, and we want to find out the current at the center of the circular wire. So as it is, we know this law, that is dB by Biot Savart law is equal to mu naught by 4 pi into I dl sine of theta by r square, or in vector form dB vector is equal to mu naught by 4 pi into I into 4 pi into I into dl vector cross r vector divided by r cube. What is r cube? The r cube, suppose if there is a current element, like this current is flowing in a conductor, at this point we want to find out between this current element, the distance between the current element and the point at which we are interested to find out magnetic field, that is denoted by r vector, or in magnitude it is r. R is basically the distance between the current element and the point at which we are interested to find out. This is the magnitude form of Biot Savart law. This is the vector form of them. And here, suppose we take a dl element. This is a dl element, and this distance is r vector, and dl is also a vector whose direction is along the current direction. The direction of dl vector, as it is we have already seen, is along the direction of current. This already we have seen. Now it means this we can easily note it out. It means the dl vector in enlarged form. This is dl vector in this direction, and r vector from the center O, this direction r vector. So dl here and r is here. What is the angle between dl and r vector? 90 degrees. That is theta is equal to angle between dl vector and r vector. Theta is equal to 90 degrees. That we can use it here also. So we can say dB is equal to mu naught by 4 pi into I into dl into sine theta is equal to 90 degree, and divided by r square. We take it in the magnitude form. Sine 90 is equal to 1. So the dB is equal to mu naught by 4 pi into I dl divided by r square. Now you understand what is r. This distance is called the r. We can take it as the radius vector, radius of the circular portion. Now here, if we add this, the directions, see, we can see direction can be found out right hand thumb rule or right hand palm rule. So direction is not a problem. So this is the magnitude. Now this is a portion of the magnetic field produced due to this elemental length. So we want to find out what is the entire length is producing, because this is the magnetic field produced by the small elemental length of this total length at this center. But we want to find out, it means we want the entire length. So we want to find out B. What is B? B is equal to, we will integrate B. It means on integration this will become B. So it means we have to integrate this right hand side also. 4 pi into I divided by r square into dl r B, where B is equal to total magnetic field produced at O due to this entire portion of the conductor, where dB is this portion, how much magnetic field is producing at this point. So now B is equal to, we can take, because it is constant, we can take mu naught by 4 pi. So what else? We can take I also out, and R also out, integral dl. It means, what is dl? If you are integrating dl, it means it gives the entire length. Entire length means circumference of the wire, 2 pi into radius. So dl, so therefore B is equal to mu naught by 4 pi into I divided by R square into this portion 2 pi into R. This will become mu naught by 2R square, we get it. So 2 pi we will take it that side so that it can get cancelled with this one. Mu naught by, so this and this get cancelled. So mu naught into R into I into 2 pi divided by 2 pi. So this is the expression, mu naught by 2R into 2 pi divided mu naught I. It means this can be realized. What is the direction? See, if the current is flowing in the upward direction, it means we can find out at O it is inward. It is inward. This side it will be outward. It depends upon, suppose if the current is flowing downward direction. Downward direction means this side will be outward and this side will be inward, reverse. So it can be found out using right hand thumb rule or right hand palm rule. Okay, no problem. So we can write the magnetic field here in this case at O is inside, that is into the plane of the board. We can write B can be simply written as mu naught by 2R. This we can cancel it into I, mu naught 2R into I, mu naught by I into 2R into 1 by 2 pi. This is the standard form for everything, plus what is this? There is 1 pi. This is what is this? This is how much at center, what the circle is subtending an angle. The circle is making an angle of 2 pi. So subtending means it is how much angle it is making with this center. That is angle subtended by circle. This is 1 by 2 pi. This is 1 by 2 pi. And angle subtended is equal to, which is nothing but 2 pi. That is 2 pi divided by 2 pi. This is a standard formula. So we can adapt it this in for full circle. This is for the full circle. For semicircle means we will write the same formula. Angle subtended for semicircle means it will be pi. At O they will make a angle of pi. So here we will write pi, here 2 pi. So this formula will be easier this way if you remember. This way also we can remember the formula, which is equal to mu naught by 2Ri. This can also remember mu naught 2R into I. This and this get cancelled, but we will write in this fashion. So this also valid formula, and this also valid formula, and this will be for different structure, for different style of semicircle or a segment of the circle. We can use this formula easily and find out the value. Now for semicircular wire. See, already we have seen for circular wire, this is the magnetic field. Semicircular means circular wire, this is the magnetic field, magnitude of magnetic field. For semicircular means multiplied by this total magnetic field multiplied by half, because semicircular means half of the circular. So semicircular means how this is the, earlier it was semicircular. What is the angle at O? We want to find out. See, theta made by the semicircle is equal to pi, because the angle subtended by O is equal to pi only. So this we can directly take out the answer, but let us see. What is dB? Now see here, this is the R vector. and this is the DL, and the current is flowing like this. So this means DL vector will be along this direction. It means this is DL vector, and this is R vector here. This is DL vector, this is R vector, and angle between them is equal to 90 degree. For semicircular wire, we can write dB using the magnetic field produced by the small elemental length at the center of the semicircular wire is equal to mu naught by 4 pi into I dl into what is theta here? Here theta is equal to 90 degree, dl sin 90 divided by the distance r square. This r square or dB we can write, we will take everything out, mu naught by 4 pi into I into 1 by r square into dl because sin 90 is equal to 1 here in this case for semicircular. Now what is B? B means if you want to find out B is equal to integral of dB is equal to mu naught I by 4 pi r square into integral of dl. What is dl here? The dl for semicircular, dl for circular it is 2 pi r, in half of it is equal to, for that is pi r. dl, integral of dl is equal to pi r because for full circle it is circumference 2 pi r, half of it is equal to semicircular. Therefore if we integrate this for entire length we will get pi r. So very simple, circumference divided by 2, that is the dl. Therefore B is equal to mu naught I divided by 4 pi r square into integral of dl is equal to pi into r. So is equal to mu naught I divided by 4 pi r into pi, or this we can write mu naught I divided by 2r into pi and divided by 2 pi. This 2 into 2 pi. So this portion is important for us, that is total magnetic field. This is magnitude of magnetic field. This is the angle subtended by semicircle at center O, divided by 2 pi. So in general we can, direction we can find out, if the current is in this direction we can hold it, it means here it is inside, here it is outside. Direction is not a problem. In general we can write the magnitude B is equal to mu naught I divided twice into the radius of the semicircular or circular into angle subtended by at the center, it may be say circle or semicircle, at center O and divided by 2 pi. Here what is the angle subtended by this one? This is equal to pi 180 degree, that is pi. So this is pi divided by 2 pi. This is the magnitude, and obviously we can find out the direction using Fleming's right hand thumb rule or right hand palm rule, like this. So this is for circular lamina in case. Now for an arc, see this is an arc making an angle theta. First we have seen for circular wire, semicircular wire. Now we will see for an arc, because this is the circle, a portion of the circle, that is an arc. What is the magnetic field produced by the current flowing in a small segmental elemental length dl, and due to at this point at the center of the arc O, due to this current. So we want to find out dB. What is dB? As it is, we know dB is equal to mu naught by 4 pi, everything based on the I into dl into sine of theta divided by r square, where this is the r. This is r means the radius. See now here dl vector is like this, dl, and whose direction is in this direction because current is flowing in this direction. Current is flowing. So this is a dl vector, this is r vector, and this is 90 degree, that is theta is equal to 90 degree. Therefore db is equal to mu naught by 4 pi into I into dl divided by r square and sine 90, that is sine theta is equal to 90 degree. This is equal to 1. So now we want to find out what is b. So b is equal to if we integrate this portion, we get b is equal to mu naught by 4 pi into I divided by r square into integral of dl. See, we already must have seen in the trigonometry arc length. Suppose we call it as AB. This is arc length AB. We can write is equal to radius into angle subtended at the center. Radius into angle subtended at the center. This is, we can call it as L is equal to R into theta. So from here B is equal to mu naught by 4 pi into I divided by R square into integral of dl. Integral of dl is equal to total length, because if you integrate we get this arc length. From here we get the total arc length. That arc length is equal to r theta. R into theta is equal to mu naught by 4 pi into I divided by r into theta. So we can make it in an easy way. Mu naught by 2. So here 2r, mu naught by 2r, mu naught by 2r as it is, into I into this 2 pi, it will become 4 pi will become 1 2 here, 1 2 pi here into theta. That's all. This is common for every circular portion. The theta is equal to angle, this angle, theta angle subtended at O due to arc AB. So if it is semicircular, this will be pi. If it is full circle, it will be 2 pi. If it is a angle with theta, this will be theta by 2 pi. This is the magnitude. Of course, direction can be found out using the Fleming's right hand thumb rule or Fleming's right, that is right hand palm rule or Fleming's right hand thumb rule. For easy remembrance, we can write for circular wire, that is circular wire means this will be circular wire with a radius, or semicircular wire with radius R. This is center O, this is center O, segment, line segment, this is E, B, making an angle theta and its radius is R. So what is angle subtended at the center by O? Here theta is equal to 2 pi. For semicircular means theta is equal to, this is equal to pi. Here theta is equal to theta. We will substitute in place of theta here. Theta is equal to 2 pi, 2 pi, 2 pi get cancelled. So the result is mu naught I by 2r. That is the magnetic field produced at the center of a circular wire is equal to mu naught I divided by 2r. Here the magnetic field is equal to mu naught by 2r, mu naught by 2r into I into theta is equal to pi divided by 2 pi. So this cancel is equal to mu naught I. We will take half of this multiplied by half of this value, mu naught I by 2r into 1 by 2. 2r into 1 by 2 are nothing but mu naught I by 4r. If I here, what is r? So the length is equal to this portion, the r into this theta, r into theta. So what is magnetic field? Magnetic field is equal to mu naught by 2r into I, whatever may be the angle divided by 2 pi, the general formula. For circular it will become 2 pi, semicircular it will become pi. If any angle is given other than semicircular and circular, it will be the angle subtended at the center. This theta will come here. This is the general formula. And of course the direction, since it is a vector, direction can be found out. A right hand thumb rule, a right hand palm rule. Thumb rule and palm rule. That's all about this one. You have to remember only this formula, that is the magnetic field is equal to mu naught by I into 2r into whatever may be the angle subtended at the center divided by 2 pi. If you remember, we can calculate for any circular portion.